So in this section, I want to say a few words about sampling, taking a sample from a population. Now, obviously, investigating a whole population would be best, but even if we lived in a moderately sized city of, say, 2 million people, if I wanted to get data on all 2 million people, it could be very time-consuming to send investigators out to get data on those 2 million people. It would be very expensive as well, you can imagine, and if we upscale that, it gets even worse. Now, fortunately, that's not always required. We do have what we call inferential statistics, and that's what we're going to learn about. We take a sample from the population and we investigate that sample only as a representation of the larger population. Imagine we knew what a patient parameter was. By some divine intervention, we knew what that was, and we took a sample and we calculated a sample statistic, and those two differed from each other completely. Then we know something went wrong. Some error happened. There was some bias was introduced. Now, the number one solution for that is always to make the sample as big as possible. Large sample sizes solve many problems when it comes to random sampling. Now, think about these things. If you read a journal article, again, as I say, the aim is to use those results and infer it to the population that you are seeing. In order to do that, think about certain things though. Is that population from which the sample was taken even the same as the population that I'm dealing with? Let's take an example of gastric carcinoma, say in the Far East, say in Japan. You can do a beautiful study there, absolutely correctly randomly sampled, good statistics can infer to that population. But is the population of patients with gastric carcinoma in Japan, is that the same as the population with gastric carcinoma in Europe or Northern America? You've got to ask yourself that question. Remember, not all populations and not all diseases really are the same throughout the world. And then always look for introduction of some bias, even if the populations are comparable. Was there any introduction, was there any bias in selecting those patients? Very important to look out for. Now, when we talk about a sampling error, that is actually what happens when everything goes right. The random sampling selection, it was really done properly. But because it is just a sample, there is a chance that it slightly differs from the population from which it was taken. And that can happen under the best of circumstances. And that's when we refer to just a sampling error. When we talk about bias, though, there was a systematic inclusion of some incorrect process. That sample is very different from the population from which it was taken. When you read a randomized controlled trial, don't only look for proper randomization of the larger sample set. You might take a large sample set and you're going to randomize them into two groups. Those two groups were done randomly or correctly, but as a group, does that group represent the population in which the results we want to use? And then lastly, when you do read an observational study, remember that's very difficult not to have some form of bias in there. So clearly look for the bias that was introduced, possibly introduced in the selection of the individuals from whom data was taken to do that analysis. Now, if we want to do this, we've got to strive for some sort of ideal, something that would improve our accuracy, the accuracy of investigating that sample. And there are two ways to go about it. Obviously, make the sample size as large as possible. When you read journal articles, look at that sample size. Was it as large as possible? And also, do not introduce bias. The less bias there is in that sample, the more representative it is of a whole population and the population that you see in the clinic, in the hospital, and have to manage. Now, there are four types of sampling that I want to discuss. The first one is going to be simple random selection. That's where we have a master list and everyone on the list has an equal likelihood of being selected at random. The systematic random selection, that is where we're just going to, as a system, just choose every individual equally spaced. So every 10th individual, every 20th individual on a list. We're going to look at clustering. That is where we don't have a master list, but at least possible participants are clustered in some way, and we can choose those whole clusters as a random process. And then lastly, some words on stratification. That's where there's a mutually exclusive trait in the population, which immediately separates them, and we can take participants from each of those groups.